matrix T, and we want to find the fixed points. So the fixed points are those points which are mapped onto themselves. So I take the matrix T, operate that on the coordinate xy, and I need to put a 1 in to allow the multiplication to take place, and because I'm operating on the point xy, the answer that comes out will also be xy. So multiplying the matrix out on the left, so it's 0.6x plus 0.8y plus 2, 0.6x plus 0.8y add 2, second row minus 0.8x, 0.6y 3, add 3 in the bottom line, 0, 0, 1, that equals x, y, 1. So the top rows, equating the top row, the 0.6x plus 0.8y plus 2 equals x, and the second row minus 0.8x plus 0.6y plus 3 equals y. So take the x to the other side, then minus x, that's minus 0.4x plus 0.8y plus 2 equals 0. And the second one minus 0.8x, take the y over, minus 0.4y plus 3 equals 0. Then rewrite them, take the 2 over, so I got minus 0.4x plus 0.8y equals minus 2 for the first one, and the second one is minus 0.8x minus 0.4y is minus 3. There's my two equations. Look at the coefficients of y. If I double the second one, I can then eliminate the y, so I'll multiply the second one by 2. So doubling the second one, that's minus 1.6x minus 0.8y is minus 6. And then coefficients of y are the same with opposite signs, so you simply add up the two equations. So on the left that's minus 2x, and on the right that's minus 8. So x is minus 8 shared by minus 2, so x is equal to 4. And then substitute in to the first equation. So I got minus 0.4 times 4 plus 0.8y with minus 2. So that's minus 1.6 plus 0.8y is minus 2. So 0.8y minus 2 add 1.6 is minus 0.4. So y is minus 0.4 divided by 0.8, which is minus a half, minus 0.5. So the fixed point is 4 comma minus 0.5. So because I got a single point as a fixed point, it must be a rotation. It must be the centre of the rotation. So for part B is asking me for the centre and the angle of the rotation. So the centre I'm just picking up from the first part. That's 4 comma minus 0.5. And then to find the angle of the rotation, if I take the matrix, the rotation matrix is this one here, and then look at the top left there, the 4 entries there, so the 0.6, 0.8, minus 0.8 and 0.6. Compare that to your rotation matrix. Okay, then I can see there that cos theta is 0.6 and sin theta is minus 0.8. So I solve these two equations. Remember, there's two answers between 0 and 360, and I want the common angle to those solutions to get the rotation. And the angle of the rotation, remember, is going to be going in an anti-clockwise direction, so that's what that matrix definition is for that matrix there. So calculator, shift cos 0.6, shift cos 0.6 is 53.1. So cos theta equals 0.6, that's theta is 53.1. The second angle, just looking at the symmetry with the graph of cos graph, just like that. And 0.6. So that's the first angle, 53.6. The second angle there is 360 minus that. Uh, 53.1, sorry, not 6. So the two answers here are 53.1 or I take that from 360. And then second angle, sine theta is minus 0.8. So I do sine theta plus 0.8 first of all. So theta shift sine 0.8. That's 53.1. Okay, so minus 0.8. It's going to be that angle and that angle. Positive 0.8. Symmetry there, that's 53.1. So the two angles are 180 plus 53.1 or 360 minus 53.1. So that's 233.1 or 306.9. So the angle I'm seeing twice is the 306.9. Therefore the angle of rotation is 306.9 degrees anti-clockwise.